All right, lots of stuff to get through. I do not want to see your launcher labs out because today we need to focus in on today. Launcher labs can be focused in on later on. Okay, those launcher labs are due if you haven't done it yet. Those launcher labs are due on Thursday, which means Wednesday after school is the last day to launch if you haven't launched yet. Okay, so you have to get your launch in by Wednesday after school. Okay. Looking ahead, week from where are we at? No, 2 weeks from today. Okay. 2 weeks from today, we'll be having your test. It will cover 6.4 and 6.6. You're in 6.6 right now with complex numbers, and we'll get into some roots and some powers and all that fun stuff this week. And then next week is polars. Polar numbers, polar equations, all that fun stuff. Okay? So that will be what your test is on. Then the day after that, the 3rd, the 8th of May, we'll be taking the EMPT. That's the one where you got to bring your Chromebook, and same test you took at the beginning of the year. We'll be retaking that one. Okay? And then it's on to the final and getting your final ready to go. Your final will be on the 14th and 15th of May. That is a Tuesday and a Wednesday. It is a 2-day test. In the past, we've done it a couple of different ways. This year, we decided that we are going to go with 2 separate days worth of packets. So, because the turnaround time is so short that we have to have them corrected. So you're going to take them Tuesday and Wednesday. We have to have them corrected and back to you for Thursday because you have to decide whether or not you're taking the NTC grade.
Do you think that the NTC test will be curved at all? Or will not be curved?
The actual NTC test will not be curved.
Like for this,
We cannot curve the NTC test. We can curve it for the Wausau School District portion of the dual credit. Yes, we can do that, but when we for their grade, it cannot be curved.
Yeah. But like for our score, like going into our grade book, will that be curved?
Depends on that. That's always an after we get done and get graded and scores and shakeouts and all that stuff. Okay. So we are in your note packet. We should be on a fresh type sheet of paper, maybe. Let's see what we got here. We do have some warm-ups going on here, and then we're changing complex numbers into standard form. Okay? So if you got some space, convert these two into trig form, please. Convert those two into trig form. I know we're going back like almost a week, but yeah, got to convert those into trig form. So in order to put this into trig form, we need to have an R value and we need to have a theta value. So our R value is going to be 3 squared plus 4 squared, and then we're going to take the square root of that. That's 9 plus 16, that's 25. So our R value is 5. Then we need to find the inverse, our reference angle. In this case, because it's in quadrant number 1, because this is also equal to 3, 4, that's in quadrant 1. So our reference angle is our actual angle. Inverse tangent of 4/3. Inverse tangent of 4/3 gets me 53.13 degrees. So the trig form here would be Z sub 1 is equal to 5 CIS of 53.13 degrees. Yes? Yep.
R value in Z sub 2 is going to be 5 squared plus negative 12 squared. That's going to be 25 plus 144. That's 169. That's 13 for our R value. This one we have to do a reference angle because we are not in quadrant number 1. So we're going to do the inverse tangent of 12/5. Inverse tangent of 12/5 is 67.38. This complex number resides in quadrant number 4. So that is my reference angle. So since we are in Q4, then actual theta is going to be 360 degrees minus my reference angle. So that's going to be 300, 293, 292.62. So Z sub 2 then is equal to 13 CIS 292.62. Agree with that? Okay. Today we're going to change a complex number from trig form back into standard form. So last week, Wednesday, we went from complex number form into trig form by doing that R, by doing that theta, and doing all that CIS stuff. Well, now we just have to go the other way. We just simply take this 8 and distribute it into the set of parentheses, into the CIS. Okay? So then this is going to become 8 cosine of 135 degrees plus 8I sines of 135 degrees. The trig value at 135 gives me a cosine value of negative root 2 over 2. So this is 8 times negative root 2 over 2 plus 8I times the sine value is square root 2 over 2. So this simplifies to be negative 4 square roots of 2 plus 4I square roots of 2. Whenever we can be exact, we should be exact. Okay? Unit circle angles, we should be exact. Non-unit circle angles, round. Good on that one? Yep. Try that one. Cosine at 3 pi over 2 is 0. Sine at 3 pi over 2 is negative 1. Negative 6 times 0 is 0. Negative 6 times negative 1 is positive 6 times I is 6I. Now, if we wanted it in true complex number form, it would be 0 plus 6i. But we're okay with it just being imaginary. Okay? So, let's try some operations here going on with complex numbers. Just that one. Yep, awesome. Okay. All right. So, we want to multiply those two complex numbers together. So z sub 1 times z sub 2 is going to equal 3 plus 4i times 5 minus 12i. Okay. See why we did the warm-ups? Wait, nudge. Okay. Okay. All right. So how am I going to multiply those two together? Double distributive. I grew up. I called it FOIL. First, take the first of both parentheses, take the outer two, take the inner two, and take the last two in both parentheses. I called it FOIL. But yeah, I knew what you were talking about. Okay. So we're going to take this 3 and we're going to distribute it in there. 3 times 5 is 15. Then we're going to take this 3 and we're going to distribute it in there. 3 times negative 12i is negative 36i. Then we're going to take this 4 and we're going to distribute it in there, and that's going to give me 20i. Then we're going to take this 4 and we're going to distribute it in there, and that's going to give me negative 48i squared. What do I know about I squared? It's negative 1. So really this term right here is positive 48. Okay. So that's positive 48, and then we've got 15 minus 16i. So I would call this z sub 1 times z sub 2 is, what is that, 63 minus 16i? 58, 63 minus 16i. I would concur with that. Yes? Okay. And that's great, and that's a wonderful way of doing things. Don't get me wrong. Super simple, very easy. Downfall is that if we had rounded numbers like we were talking about before there for our complex numbers, we just got rounded numbers in there. And then we're compounding our rounding, and we're rounding and we're rounding. But it still works. Okay? It's still good. But there's gotta be a better way. So what I would like you to do is I would like you to convert those 3 back into complex, or into trig form. So we already did the first 2. So we did z sub 1, and we said that that was 5 CIS of, was it 53.13 degrees? For the first warm-up. Yeah? And then we did z sub 2 already as 13 CIS of 292.62 degrees, correct? Check me on that one. I'm literally going off of memory. Okay? All right? So we just need to convert z sub 1 times z sub 2 into trig form. Okay? So that means I'm going to need an r value. So that's going to be 63 squared plus negative 16 squared. And I'm going to take the square root of that. Ooh, those are some big old numbers. 63 squared is, at first I got to turn the calculator on. 63 squared, where's squared key? There it is 3969. 16 squared, I think, is 256. Add those together. Yes. And what is the square root of 4,225? 65. So our R value is 65. Love it. Okay. Then we needed to find a theta. Is this in quadrant number 1?
Now it's in the
Quadrant 4. So that means we got a reference angle here. So that's inverse tangent of 16 divided by 63. Divided by 63, let's do that. Second tangent, second answer gets me 14.25. Okay. Because we're in quadrant 4, that's going to be actual theta is going to be 360 minus my reference angle. So actual theta is going to be 345.75 degrees. Do we agree with that? Yeah. Okay. So Z sub 1 times Z sub 2 then is going to be 65 CIS of 345.75 degrees. Yes? One of the great things about math is there's always a pattern. What do you got, Joy?
Do you want me to say
Sure.
the R value times the other R value? is equal to R value?
So these two right here get multiplied to give me that, is what you're saying.
And the angles are added.
And then the angles, this angle and this angle get added together to give me that angle. Anybody want to back up that pattern?
Yes.
Agreed?
Huh?
Yeah. Because that's the pattern. Okay? When you're multiplying complex numbers in trig form, you multiply the R values and you add the theta values. Okay? I don't know if I have that on a slide. I do not have that on a slide. Okay? So the pattern is and this only works in trig form. We multiply our R's and we add our thetas. Okay? And that gets us right to what we need to do. Okay? Love it. Good. Good stuff. Now, let's go with dividing. Okay? So now, Z sub 1 divided by Z sub 2 is going to be 3 plus 4i divided by 5 minus 12i. Do I like that as a complex fraction? Yes, you're shaking your head. What don't you like? Well, I don't. But there's one glaring thing that I don't like about it. It is actually simplified as far as you can go. That was a good try, though. Good try, Sadie. What do you got, Trina? What don't you like about it? Not so much the complex number in the bottom, but the imaginary part in the bottom. I don't like the I downstairs because the whole bottom is a complex number. Yep. But I would like the bottom to just be a real number. Yep, exactly. Okay. So what am I going to multiply both top and bottom by in order to get rid of said complex number downstairs? The conjugate is what it's called. Yes. So we're going to multiply by 5 plus 12i on the top and 5 plus 12i on the bottom. So when we do that, now we got to do some more maths. Maths is cool. Okay? So we get, on top, I get 15 plus 36i plus 20i plus 48i squared. On the bottom, I get 25 plus 60i minus 60i minus 144i squared. Agree? Okay. So this one up here becomes minus 48. This one down here becomes plus 144. And these two cancel each other out. So that leaves me with z sub 1 divided by z sub 2 is negative 33 plus 56i all over 169. Do you agree? Yes? Okay. Which in all reality is negative 33 over 169 plus, plus 56 over 169i. Because now it's in a plus bi form. Agree? Okay. Once again, let's convert those three into a complex number, or into trig form, and look for a pattern. Once again, z sub 1 was equal to 5 CIS of 53.13 degrees. Z sub 2 was 13 CIS 292.62. Yay? 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 Let's do twice. Okay? So now we need to convert this one into wonderful form. I'm going to use that black part. So my R value, I'm going to utilize my calculator because I like my calculator. Oops, I should probably remember what they are. Negative 33 over 169 and 56 over 169. Okay. So we've got the square root of, open parenthesis, tap the brakes, escape. Why is it giving me that? There we go. Oh, oops, come on now. There we go. We need a fraction, and that fraction is going to be negative 33 over 169, and I am going to square that. Then I'm going to add to that the fraction of 56 over 169, and I'm going to square that one, and that gives me a fraction of 5/13. Trin's shaking her head up here like she knows the pattern already.
Well, I know it makes sense.
What do you think the pattern is up here, head shaker? So divide the R values, does that work out? And then you said subtract the thetas, right? Okay, so Trin's guess is we're going to subtract the thetas. Let's check that. Okay, so we've got the inverse tangent of a fraction. So that's going to be 56 over 169. And then we're going to divide that by 33 over 169. And that's going to come out to be 59 point, let's call it 49. We all agree 59.49. Okay. But it's in which quadrant? It's in quadrant number 2. So that means that our quadrant number 2, our actual theta is 180 degrees minus that reference angle. So minus 50 is 130, minus 9 is 121. So I get 120.51 degrees for my actual theta. Yay? Yes? Okay. So then this is going to be CIS 120.51 degrees. That's a really weird 5. Okay? So Trin's guess on the pattern was we divide these two. Does that hold up? That holds up. Trin's guess was subtraction on these two. Does that hold up?
Technically.
How?
Because it's negative 239.49, which is
Because 53.13 minus 292.62 is how much?
negative 239.49.
53.13 minus 292.62 gets me negative 239.49. That's a great question, Miss Bell. Why? Why? Because we like positives, we like first lap angles, right? Okay. Because remember, way back, I know, Miss Bell, this is going way back to like late September, early October. We learned that if we added 360 degrees on the unit circle, we're back at the same spot. Or if we add 2 pi, we're back at the same spot. Okay? So if we add 360 degrees there, then this gives me 120.51 degrees. Sha-bam. Okay? So multiplying and dividing complex numbers in trig form is relatively easy. You multiply the r's, add the thetas. You divide the r's, subtract the thetas. Order matters, though, in that subtraction. Not so much in the addition one, but in the subtraction one. Yes, ma'am.
So I feel like this is like more work than what we did the first time. So why do
What do you mean?
like we have to do more things? But then like why like this was simple.
100% more. Because we already did the work on this stuff. You know what I mean? We did that work as our warm up, and so we could have just said, I could have literally on that last slide told you, yeah, you multiply the r's, boom, done. You add the thetas, boom, done. You know what I mean? Yeah. There is a little bit more to do, but where we're going to, it's much easier to do it this way. Yeah, I promise. Okay? With that being said, what I would like you to do right now is I would like you to find z sub 1 times z sub 2 off of these two in trig and standard form. Trig form, remember, is CIS. Standard form is A plus BI. Okay, so we're combining everything that we've learned today into 1. And then find me z sub 1 divided by z sub 2 in both trig and standard form. I don't need z sub 1 and z sub 2 in standard form. I already know them. Okay? So trig form, z sub 1 times z sub 2 is going to be 6 times 3 is 18. CIS 210 plus 60 is 270. 270 degrees is straight down, so that's going to be 0 minus 18i. Or just negative 18i for standard form on that one. What's wrong, my dear? Okay, so then because really it's this written out, this is 18 times the cosine of 270 plus I sine of 270, right? Right? Okay, well, what's the cosine at 270? Straight down at 0, right? So that's why it's 0. What's the sine at 270? Straight negative 1. Negative 1 times 18 is negative 18 plus the I. Yep. Yep. Okay. Then we needed to find them divided. So then z sub 1 divided by z sub 2 is going to be 6 divided by 3 is 2. CIS of 210 minus 60 is 150 degrees. Cosine at 150 is negative root 3 over 2. So that's going to be negative square root of 3 plus sine at 150 is 1/2 times 2 is 1. So then that's just going to be I. Yay or nay? Yay, because it's unit circle. Everything's on unit circle, so we can go exacts with it. Okay, not round. Okay? I think that was it on this one. What I would like you to do now is I would like you to do this one, where you've got to find z sub 1 times z sub 2 and z sub 1 divided by z sub 2 in standard form. Trig form. So I've got an R value here of 8. I've got a theta prime of, what's that? So sine is root 3, so that's 60. Which gives me an actual theta of 120 degrees. Do we all concur with that? Yes? So this z sub 1 here is 8 CIS 120. Yes? Okay. Then I've got z sub 2 gives me an R value of 2 and a theta, because it's in quadrant 1, of 60 degrees. Concur? So that gives me z sub 2 here as 2 CIS of 60 degrees. Yes? Yes. Okay? So, multiplying them out, that's going to give me z sub 1 times z sub 2 as 16 CIS of 180 degrees, which is the same as negative 16. Yes. Okay? Z sub 1 divided by Z sub 2 is going to be, that's going to be 8 divided by 2. That's going to be 4. CIS of 120 minus 60 is 60. So then that's going to be 2 plus 2I square roots of 3. Yes? Okay. Your homework for this evening prior to class tomorrow is to do number 6 there at the bottom of that page. That is your entrance ticket. Oops, not pass out practice sheet, or are we? Nope, we're not. We're waiting until tomorrow. Yep. So your job is to do number 6.